This problem is an example of a rational equation. Remember, rational equations are equations that have fractions. And oftentimes, the variable will appear in the denominator of one or more of the fractions in our equation. This happens to be the special type of rational equation, where we have a single fraction equal to a single fraction. And remember, that particular type of rational equation is called a proportion. When I have a single fraction, no other terms, just a single fraction, equals a single fraction, no other terms, just a single fraction, that's a proportion. And the technique that I can use to solve the proportion is cross multiplication. We generally signify cross multiplication by drawing this x to help us know what we're doing. We're going to take the numerator of this fraction and multiply it times the denominator of the fraction on the other side of the equation. And that's a binomial, so to show that I'm going to multiply this numerator of 2 times that whole denominator, I'll put that whole denominator in parentheses since it's a binomial. Then I'm going to take the numerator of this fraction times the denominator of the opposite fraction and set those two quantities equal to each other, which creates a new equation that no longer has fractions. And now I just solve this resulting equation. Well, let's get rid of those parentheses so we can see what kind of equation we have. Since the exponents here are just 1, makes me think I have a linear equation. This will be 2x plus 18 equals 6x minus 6 when I multiply through. Let's subtract 2x from both sides. So I have 18 equals 4x minus 6. And then add 6 to both sides to isolate the x term. So 24 equals 4x. Dividing both sides by 4, I get a solution of x equals 6. This was the special rational equation, the proportion. Single fraction equals a single fraction. So I cross-multiplied in order to set up a new equation that I could solve to find the answer.